Hello, I am Mad Professor Dr. Knowledge. If you want to hear some fun fact from everyday life, welcome and listen. Why do rainbows appear on soap bubbles? Answer: there is hardly a person who hasn't blown soap bubbles at least once as a child. Their playfulness is a source of delight for children, and watching them float through the air is truly relaxing. You have probably also noticed that bubbles are not completely transparent, but instead display shifting rainbow-like colors on their surface. Have you ever wondered why this happens? To find the answer, we searched the web and came across some interesting facts. But first, let's explore how a soap bubble is formed in the first place. You can't make a bubble with water alone. We all know that. So what does the soap solution we add actually do, and why does soap foam at all? A simple explanation for why soaps foam is that they contain chemicals known as foaming agents. Common foaming agents used in consumer products include ammonium lauryl sulfate and, even more commonly, sodium dodecyl sulfate, sometimes also called sodium lauryl sulfate. In addition to acting as foaming agents, these ingredients also function as surfactants. A surfactant reduces the surface tension of water and can break down oil or sebum on the skin, allowing dirt to be washed away. However, to truly understand how bubbles form, a slightly more complex explanation is needed. At the heart of it all is the surface tension of water. When soap or detergent is added to water, the surface tension decreases. Detergent molecules actually live a double life. On the one hand, they are attracted to water, and on the other to grease or fat. This is precisely why soap is so effective at cleaning. Grease cannot be washed away with water alone, because it does not mix well with water and is in fact repelled by it. A soap molecule has two distinct parts. One end is hydrophilic and attracts water, while the other end is hydrophobic and attracts fat. This allows fat molecules to be captured and detached from our dirty clothes and then rinsed away together with the water. Soap bubbles form in a similar way. A soap bubble is a spherical soap film filled with air or another gas. The film consists of a thin layer of water trapped between two thin layers of soap molecules. The soap molecules try to escape the water molecules with their hydrophobic ends, so they gather at the surface of the bubble. As a result, the water molecules are forced apart, reducing their surface tension just enough for the bubble to be inflated without bursting immediately. Bubbles are round because everything in nature tends toward optimization and minimal energy loss. A sphere is the most efficient shape as it has the smallest possible surface area for a given volume. Nature knows best. Now we've strayed a bit. Hopefully it was still informative. But let's return to the original question. Why do rainbows appear on soap bubbles? We now know that the wall of a soap bubble is a very thin film made of soap solution and water. This wall is extremely thin, less than 1/10 the thickness of a human hair. Light passes through this film, and part of it is reflected from the outer surface, while another part is reflected from the inner surface. Because the bubble wall is so thin, at certain angles these reflected light rays become aligned. Their wave peaks coincide and reinforce one another. This phenomenon is technically known as phase interference. If these reinforced rays of a particular wavelength reach our eyes, we will see that color, for example blue, more intensely than others. This is why the angle at which light hits the bubble and the angle from which we observe it are so important. Because the thickness of the bubble wall is not perfectly uniform across its entire surface, different wavelengths come into phase at different points, producing a mixture of colors that seem to drift across the bubble. Soap bubbles are also a small wonder of nature. At home, you can try a fun and interesting experiment. Use a straw to blow a new bubble into one that is resting on a surface. The wall separating the two spaces will be perfectly flat. If a bubble is made up of, for example, 3 connected sections, the angles between the walls will be exactly 120 degrees. Nature always strives for perfect optimization and balance.